Okay, let me try this integral. It is not as easy as I thought it was. Now, the log something, right, has to be positive. So actually this is the absolute value. Now let me use the regular parentheses. So we consider that this is as absolute value. Now, first, I'm considering the square root, right? So I let x be cosine square t. So obviously I want to get rid of the square root. So the integral becomes natural log. This will be sine t, right? Minus cosine t. And d cosine square t. Okay, good. Then cosine square is 1/2 1 plus cosine 2x, right? So d cosine square t can be d cosine square t is equal to 1/2 d cosine 2t. Okay. Yeah, that's what I meant. So d cosine square is 1/2 d cosine 2t. So let me change this one to, I bring half outside. This becomes a natural log sine t minus cosine t d cosine 2t. Okay, good. That's what I meant. All right. Now then, well, let me do it this way. This is 1/2 natural log bracket 1/2 root sine t. And let me go slowly. Just watch what I'm doing, because it's rather complicated. So I'm not root 1/√2t here and there, and I cancel that √2t by multiplying the √2 outside. And cosine 2t is sine half pi minus 2t. Right? That is obvious. Now you see the reason I'm doing this way, because 1/√2 is a cosine quarter pi. So sine t times cosine quarter pi. That is this. Minus 1/√2t is a sine quarter pi times cosine t. So that becomes a sine t minus quarter pi. See? Therefore, this becomes a natural log √2t multiplied by sine t minus quarter pi. Okay, this one is here. This becomes this. Okay, that's the detail. Now here, I want to have this I want to have this kind of form so I can bring new variable. This is a d sine. I take 2 outside, becomes quarter pi minus t, isn't it? Yeah. This is this. Now, t minus quarter pi minus t. I can switch these, change these two, because sine is odd function. When I switch this one, I bring negative outside. Okay, become d sine 2 t minus quarter pi, 2t minus half pi. I switch this one by bringing negative outside. Negative outside. Now it's negative. So now see, I'm ready for bringing a new variable. So I bring a new variable. Theta is equal to t minus quarter pi. Negative half. This is natural log root 2 sine theta, isn't it? D sine 2 theta. Yeah, that is a new integral. Looks much better. Now here I'm going to continue using by parts. This is a u, this is dv. So this becomes half uv, u times this, right? uv. So this is v, this is u, root 2 sine x sine theta, minus v du, minus change it. V du, this is v. Du is this derivative with respect to theta. So that is root 2 sine theta times the derivative of this, which is root 2 cosine theta and d theta. Wow. A lot of details. Okay, then this one is equal to 1/2 negative sine 2 theta natural log root 2 sine theta. This is cancel out, right? Plus half. This is sine theta. This is 2 sine theta cosine theta times theta becomes square. Finally, we get much easier, much better integral. 1/2 sine 2 theta natural log root 2 sine theta. 2 cancel out, plus cosine square theta d theta. Yeah, finally we see the light in the tunnel. So the integral is almost finished. Now this integral is rather easy. Cosine square is equal to 1/2, right? 1 plus cosine 2 theta. So that integral is easy. Is equal to 1/2 theta plus 1/4 sine 2 theta, right? So that is this integral. Let me change the pen. Now, so finally we have this. Negative half sine 2 theta natural log square root sine theta plus, that's the integral, right? Half theta plus quarter sine 2 theta plus c. So the integral has been done. We have to convert back theta to x. Since we have two substitutions, so we have to convert the theta to t, then t to x. Okay, now let's consider one by one. There's 2 theta. Now, 2 theta, sine 2 theta is sine 2t minus quarter pi, isn't it? Which is equal to, no, half pi, sorry, times 2, huh? Times 2. This is a negative sine half pi minus 2t, yeah. So this is equal to negative cosine 2t. So sine 2 theta is actually cosine 2t. Okay, cosine 2t, yes. Right. Yes, good. Then, what? Let me do one by. It's quite some. What's the t? T here. Now x is a cosine square t. That is the first substitution. Therefore, root x is equal to cosine x. So t is equal to arc cosine root x. Okay, that is one thing. Now the other thing is that cosine 2x is equal to cosine 2t rather. Sorry, cosine 2t is equal to 2 cosine square t minus 1, isn't it? Therefore, this one is equal to cosine 2 is x, so 2x minus 1. So that is another important conversion. Cosine 2t is 2x minus 1. Okay. Now let's sine 2 theta is negative cosine 2t. So this becomes positive, right? Half cosine 2t. That is for this one. See the reason here. Now, natural log. Well, remember the substitution here, right? We can do this. This is equal to. This is equal to, well, how should I put it? This is this is a natural log one over root 2 1 over root 2 sine theta. Sine theta is a sine t minus quarter pi. Theta is what? Theta is now, what's the theta? Theta is t minus quarter pi. What's the t? T is a cosine. Or we can simply use the direct substitution. Half theta is half t minus pi over 8, right? That is for half theta. Theta is this. And this is for half, right? Then plus 1/4 sine 2t. Sine 2 theta. Let me see. Where is the sine 2 theta? Sine 2 theta is cosine, negative cosine 2t. So it becomes a negative quarter cosine 2t plus c. Sine 2 theta. Where's 2 sine? Sine 2 theta is sine 2 theta minus 2t because theta is this. Okay, so this is equal negative cosine. So it's been ready. Now I convert from theta to t. Now then from t back to x. Then we finish. Right? Okay, now finally the conversion. Cosine, where's cosine 2t? Well, cosine 2t is a 2x minus where is the here. T is arc cosine, tangent cosine square. So root x is cosine t. T is equal to arctangent. Cosine 2t is 2 cosine square minus 1. So cosine 2t is 2x minus 1. So this one is equal to 1/2 2x minus 1. Let me change it. New paper. New paper. So this one is equal to 1/2 cosine 2t is 2x minus 1. Okay. Now this, I need papers again. Now this is a sine t times cosine quarter pi is 1 over root 2, right? Minus sine quarter pi is 1 over root 2 times cosine t. Then together times the root 2. So this one cancels with this one cancels with this one, becomes sine t and cosine t. So natural log sine t minus cosine t. Yeah. And plus half t. 8th pi, I don't need it because I can throw this into c, right? This goes back to c combined, so no more quarter. And minus 1/4 cosine 2t. Cosine 2t is equal to 2x minus 1. 2x minus 1, as we done before. Yeah. So now we convert back to 2x now. Left over this. T, what's the t? T is too many substitutions. X equal to this. Root x is equal to cosine t. So t is arc cosine root x. So this one is equal to arc cosine root t. So everything is done. Let me write the result. This is 1 half 2x minus 1 natural log sine t. Sine t, what's the sine t? Sine t. Sine t is equal to 1 minus cosine squared t, right? So this is equal to 1 minus t. 1 minus x, sorry. This is 1 minus x. This is a square root x. This is a half cosine arc cosine root t. And minus half x, 1/4 combined with the c, right? So that is the very answer to the integral. It's not very easy. Okay, I suppose this is correct. If I have some error, please leave it in your comment. Because I don't have the answers, so this is the result. I did it. I hope it is correct. If some mistake, please correct them in a comment. I believe this integral has a different method, and it may have a different form, but eventually, the antiderivative is the same. Thank you.